Hey guys, here we are in our second video, and I'm going to open up the kite drawing thing that we have here, and we can check that out. It'll just take a minute to get to it because we can show you different kinds of kites and lines of symmetry there. All right, I think it's right here. There we go. All right, so what do we notice? We notice that we have two lines that are the same length, right? And they are adjacent to each other. Adjacent is kind of one of those interesting words because it sounds like adjacent, right? But there's a D there. All right, so you'll see this on your vocabulary list as well, but I just wanted to write it here so that you could get an idea for what it looks like. Adjacent. It means next to each other. So you could say the adjacent house, the adjacent car, the adjacent line segments, okay? And they are equal. Now, it's going to make a kite for us, and we can see that we have one line of symmetry right down the middle, and we are able to move this point to other places, but you notice that this point and this point are on the same line, and that means that these two adjacent lines are equal sides, and these two adjacent lines are equal sides. Now, if we make them a little bit more like that, then we would also have a line of symmetry going across the middle. But since this point can be anywhere, and it can even be up here, but it's not letting me do that with the whatever we call this thing, the thing, you can see that it would not always have a line of symmetry in the middle going horizontally, only vertically, right? Okay, and we see that no matter how we make it, our two lines, adjacent lines are going to be the same size, and these two adjacent lines are going to be the same size. Okay, that one's a little bit tilted, but it still works, right? Okay, so now let's finish this up, put this away, and let's look at these two figures, okay? It's not going to open for me. Yes, I want to exit. I know it's not always the easiest, but we're going to continue working on properties, right? So we're looking at different properties, and we are going to compare these two figures. Okay, look at those two figures. We're going to see how the kite relates to other quadrilaterals in our hierarchy. Okay, can you classify the quadrilateral here on the left? What kind of quadrilateral is that? It's going to have several names, right? It is definitely a quadrilateral. It's also a trapezoid and a parallelogram and a rectangle, okay? And the most specific name for that figure is a rectangle, right? It has 4 right angles. Okay, nice. And what about the quadrilateral on the right? Is it a trapezoid? Yes. Is it a parallelogram? Yes. Is it a rectangle? Not a rectangle because it doesn't have 4 right angles, right? Okay, nice. What's the most specific name for this figure on the right? It is a rhombus because all sides are the same length, and that's the definition of a rhombus, right? Okay, now let's think about lines of symmetry for rhombuses. Lines of symmetry for rhombuses. You might know that all rhombuses have 2 lines of symmetry that go through their diagonals, right? So they would cut it in half, 2 equal shapes, either this way or that way, right? Okay, how about lines of symmetry for rectangles? You might know, and you can see on our hierarchy, sorry, that's not so straight, but 2 lines of symmetry, one going that way and one going this way, and it cuts it into 2 equal pieces, and it's at the midpoint of these 2 lines that you can cut it in half, right? Okay, now, are either of these polygons kites? Do either of them have at least two pairs of adjacent sides that are the same length and one line of symmetry through a diagonal? Okay, so our rectangle cannot be a kite because this side, right, is next door to this side, and they are not equal to each other, right? But here we see this side is adjacent to this side, and they are equal to each other. This is equal to this one. So two sets of adjacent sides. All four doesn't have to be the same, but they can be, right? So that we have two sets of adjacent sides that are the same length, right? The same longness, okay? How does knowing the properties of rectangle and rhombuses help you decide whether a figure is a kite? Because all rhombuses have two pairs of adjacent sides that are the same length because they have all four sides the same, right? So it makes sense that these two sides would be the same and these two sides would be the same because all four sides are the same. So that means that all rhombuses are also kites. Do you see that? In fact, if you look at it sideways, it even looks like what we think of as a kite, right? But all kites are not have to look exactly like the kite in the sky. Okay, and not all rectangles are going to have adjacent sides that are equal, right? Not all rectangles are going to have a line of symmetry through a diagonal. So not all rectangles are kites. Can a rectangle ever be a rhombus? And can a rhombus ever be a rectangle? Okay, so here we're looking at these shapes. This is a rhombus, and this is a rectangle, right? Now, can a rectangle ever be a rhombus? Can a rhombus ever be a rectangle? Think about the properties of those as you're thinking about that question, okay? Properties of rectangles. It has to have 4 right angles, right? Okay, so 4, I'm going to just put perpendicular line here, 4 right angles, right? What about rhombus? 4 equal EQ, that means equal sides, okay? 4 equal sides. All right? Does your quadrilateral have 2 sets of opposite sides that are parallel? 2 sets of opposite sides that are parallel. Yeah? This is parallel to this. 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 Right? They both have 2 sets of parallel lines, right? And we could even use our arrows, our arrowheads, right, to show this is parallel to this. This is parallel to this. This is parallel to this. And this is parallel to this. So that makes them both parallelograms, right? Okay. Does your quadrilateral have 4 right angles? The one on the left does. So that makes it a rectangle, right? Are all 4 sides of your quadrilateral the same length? Okay. That would have to be a rhombus, right? Are the diagonals of your quadrilateral the same length? Okay, diagonals of your quadrilateral are the same length, right? So that would be a rhombus. Can we make a square that is a rectangle and a rhombus? Can we draw a square four right angles, two sets of parallel sides, four equal sides, right? So even though we're used to this being a rectangle just has to have four right angles. So when a rectangle has four right angles and four equal sides, then it is a square, okay? Squares are quadrilaterals that are both rhombuses and rectangles. What is the sum of the angle measures of a square? Do we even need to add them up? Do we already know? 360 degrees, right? How do we know that the interior angles of everything on this page right now is 360 degrees? Because they are all quadrilaterals, and all quadrilaterals have interior angles that add to 360 degrees, right? 9 times 4 is 36, so 90 times 4 is 360. And if you don't believe this one, then measure it with a protractor and check it out, because they all add to 360. If squares are quadrilaterals that are both rectangles and rhombuses, then how many lines of symmetry do squares have? We have one right here, right? Just like a rhombus, we can go diagonal, but also just like a rectangle, we can go through our midpoints. So that makes 4 lines of symmetry for a square. One last question. Are all squares kites? What do you think? Look at the adjacent sides. This side is next to this side. They are the same size. These two are equal length as well, right? So adjacent sides of equal length means that they are also kites. All right, nice job. Let's learn a little bit more about creating a signature, and I'll see you on the next video. Or I should say an autograph, right?
All sorts of things that you can do. They all take practice, and to come up with these designs you have to play with them. And so if you've got one letter shape you don't like the look of, make it better. So I quite like this kind of more whooshy kind of thing, but I don't know. What I'm going to try and do is join the R straight to the J, so I'm not drawing an A at all. And then that kind of works. This has a look to it somehow, but I don't like the ESH, so I'm going to have to think about this. I'm going to have to think ESH, that ESH. So So you can come up with these little kind of tunes and things to go with it. So So I think a traditional kind of cursive